How do volcanic eruptions impact Arctic ozone depletion? Have you ever wondered how volcanic eruptions can affect the ozone layer in the Arctic? It might surprise you to learn that these natural events play a significant role in ozone depletion. When a large volcanic eruption occurs, it releases gases like sulfur dioxide and water vapor into the stratosphere. These gases transform into tiny particles called sulfate aerosols. This process is essential because it increases the surface area available for chemical reactions that can lead to ozone destruction. In the Arctic stratosphere, these volcanic aerosols help from polar stratospheric clouds. These clouds are important because they provide surfaces where inactive chlorine compounds can be converted into reactive chlorine radicals. During the cold Arctic winter and early spring, when sunlight returns, these reactive chlorine radicals break down ozone molecules. The presence of volcanic aerosols enhances this process, making ozone depletion even more severe. Another interesting aspect is the phenomenon of denitrification. Volcanic eruptions can remove nitrogen compounds from the stratosphere by converting them into nitric acid, which then settles out. This process reduces the availability of nitrogen species that usually help to moderate ozone loss by sequestering reactive chlorine. In a volcanic stratosphere, however, denitrification has less impact because the cloudy conditions created by volcanic aerosols favor strong ozone depletion. Research indicates that volcanic eruptions can roughly double the amount of ozone loss in the Arctic during winter and early spring compared to non-volcanic conditions. This enhanced ozone loss can reach levels similar to those observed in the Antarctic ozone hole under specific cold conditions. The effect is most pronounced when the Arctic vortex remains stable and cold into spring, allowing the chemical processes driven by volcanic aerosols to continue longer. Additionally, volcanic aerosols can influence stratospheric temperatures. While they generally cause warming by absorbing sunlight, the injection of water vapor can lead to radiative cooling. These temperature changes affect the formation and persistence of polar stratospheric clouds, further influencing ozone depletion dynamics. From the perspective of the polar regions, volcanic eruptions are a significant natural factor that can worsen ozone layer thinning in the Arctic. This thinning allows more harmful ultraviolet radiation to reach the surface, impacting ecosystems and human health. Understanding how volcanic eruptions affect ozone depletion is essential for predicting Arctic ozone recovery and assessing the combined effects of human-made chemicals and natural events on the polar atmosphere. Monitoring volcanic activity and its effects on the stratosphere helps improve forecasts of ozone depletion events in the Arctic. This knowledge supports environmental protection efforts and informs policies aimed at reducing ultraviolet radiation risks in polar communities and ecosystems. So, the next time you hear about a volcanic eruption, remember its potential impact on the Arctic ozone layer and the broader implications for our planet.